Hello friends, in this video we want to talk about packet tracer 12.5.13 troubleshoot enterprise network, and we want to use our information and also our studies to troubleshoot in this network, and we should use a routing protocol and ether channel, port security, DHCP and NAT information. And our task is review requirements, and after that we should isolate network issue here and also resolve it. And finally, we should document all of the information and all of the requirements that we have verified and investigated. You can see others in table here, and also in topology we have 3 ether channel group here, and also we have routing protocol between router 1, 2, 3. This is OSPF, and also we have port security or on, for example, PC1, and we have TFTP server here, and also we should use NAT to access to outside host. And yeah, as you know, NAT help us to translate private IP address to public IP address, and all of the internal devices can get access to external devices and can ping external. First, we should verify switching technology. Port security is configured to only allow PC1 to access switch 1 switch 1's fast Ethernet 03 interface, this interface, and we should activate port security here. As you can see, we should go to switch 1, and in privilege mode you can write here show port security, and you can see this is blank. It means there is no port security activated here. You should go to configure terminal mode, and under interface fast Ethernet 03 you can activate switch port security, and also switch port security MAC address sticky to get IP address automatic from PC1, and also devices in LAN on S1 should be in VLAN 10. We can check it. If you go to show VLAN, you can see it's better. We can write here show VLAN brief for this purpose. As you can see, fast Ethernet 03 and 04 assigned to VLAN 10, and it means it's true. And display the current state and what ports are currently assigned to VLAN 10. This is fast Ethernet 03 and 04, but rest of them, as you can see, by default is under VLAN 1 and assigned to VLAN 1, and it's by default. And PC1 should be receiving an IP address from router 1. If you go to PC1 here, we can check, can get IP address from router 1 or not. Router 1 is a DHCP server for PS1 and for LAN 1 here. You go here and you can see DHCP is activate, okay, but IP address is not true. This is APIPA. APIPA, it means they cannot get IP address from DHCP server, and it's APIPA, and you can also not see any the default gateway here. But what is the problem here? What is the issue here? Does the PC currently have an IP address assigned? No. And problem, it can be, maybe it can be DHCP on PC. It can be maybe ping between PC1 cannot ping R1. Maybe this is cable problem. Maybe this is server also. Maybe we have not configure R1 as a server also, or maybe something is wrong here, but we can find and we can investigate problem here. And as you can see here, the first problem, G01 should be a member of VLAN 10 to send VLAN 10 and to transform VLAN 10 to R1. And in this situation, you should first write here interface fast Ethernet gigabit G01 and switch port access. This is not trunk because should only um, cross and send only one VLAN here. And in this situation, you should use access. And also another thing here, change the G01 interface to be member of VLAN and set the port fast on the interface. And also we should spanning tree port fast, we should activate it. And now we can come back here and go to click on fastboard or go to IP configuration and click on maybe you can also click on static or come back to DHCP or come here in command prompt and in reality also IP config /renew and get new IP address here. And this is, yeah, this is true default gateway, and also this IP address is true. You can see also here, this is true. And we should also test connectivity to TFTP server. This is TFTP server. We can go here and ping 192.168.20.240.54 and click on fast forward. And we should wait. Yes, now they can ping each other. This is only check. The LAN connected to R3, this is LAN, had an additional switch added to topology. Link aggregation using Ether channel. Ether channel is configured on S2, S3, S4. The Ether channel links should be set to the trunk. We know that all of the links that uses in Ether channel process should be set on trunk. The Ether channel links should be set to form a channel without using a negotiation protocol. And it's also important all of the port channels should be used a no negotiation protocol. And as you know, we have two forms. Issue the command on each switch to determine if the channel is working correctly. You should go to, for example, S2 and here, and you can in privilege mode show Ether channel summary, and you can see we have port 1 and port 2. This is port 1, channel group 1, port 2, channel group 2, and you can also check fast Ethernet 01 and 02 here and fast Ethernet 3 and 4 here. If you cannot see the name of them, you should go to option, preferences, and after that you can click on always and you can see 01, 02, 03, 04, and also all of the information here. But it's very crowded here and a lot of things here. You can go here. And also SU, it means it's true. S, it means layer 2, and U, it means is used, and it's true. But it's better also we control the name of interfaces. And here also you can write here, show Ether channel summary. As you can see, we have port channel 3, but port channel 1 is blank, and it means there is no port here, and SD means down, and it should be up. And in this situation, you should go to configure terminal here, and in configure terminal you can write here interface fast Ethernet range, fast Ethernet 0, 1, and 2, and here channel group should be number 1 because port channel group is 1, and also mode should be no negotiation mode. No negotiation mode, it points out to on. As you know, we have active and passive, and also we have desirable and also on, and also auto, and we can write here on, and it will be up. Yes, and also is same process. You can check in switch 4, show ether channel summary, and both of them is SU and in use. And you can also come back here and right here to show ether channel summary, and you can see it has been fixed here. Yes, and also is true. And modify S3 to include ports F0102. We have done it, and we have also checked status and verified trunk status on all switch. We can also go to switch here, and we should uh, follow up the condition here. Show interface trunk, and as you can see in switch 2, um, we have other native VLAN. It's very important. All of the interfaces should have same native VLAN in the network. For example, for switch 2, 3, and 4, we should have native VLAN 99, and it's very, very important for all of the switches here. And you should go to configure terminal, and which interface has problem here. This interface has problem here, and interface G01 and interface G01 you should write here switch port trunk native VLAN 99. And also you can also check here, for example, do show interface trunk, and this is 9999. This is true, and it's same process for switch 4. Show interface trunk, and this is 99, port 2 and 3, and ether channel has also same, all port channels and channel groups have same trunk number and trunk native native VLAN here. And yes, also is true. And here, a spanning tree should be set to PVST plus on S2, S3, and S4. S2 should be configured to be the root bridge for all VLANs. Also, as you know, for a spanning tree, we should select any switch as root bridge. And in this instruction and in this guide, S2 should be um, selected as root bridge. We can check here, and if you go to switch 2 and right here show spanning tree summary totals, you can see root bridge 4, but it's blank. There is no root bridge here. And in this situation, you should go to configure terminal and set S2 as root bridge. You can write here spanning tree and VLAN, which VLAN, all of the VLAN, all of the VLAN. If, for example, you can use this for VLAN 1, VLAN 10, VLAN 20, VLAN 30, but in this instruction, you should use it for all VLANs here. And after that, you should say this is root or this is priority. Priority is you have choose a mode, but here you can use root, and after that it should be primary. Secondary is like alternative, but it should be primary here. And also you can use priority. Priority you should write any value, and you can also set a root bridge here. But in our instruction we can use this command here, and if you come back to show spanning tree total, you can see root bridge is not blank, and root bridge uh, used for default 1 and V30, V40, and V50, and also native VLAN 99. It has been also uh, selected. Yes, and verify DHCP R1 is a DHCP for PC1 and LAN 1, and also R3 is DHCP server for all three LANs attached to R3. You can see we have PC4, and this is LAN 4, LAN 3, and LAN 2 here, network address you can see. Check the addressing of the PCs. If you go to PC4, for example, you can go here, right here, ipconfig/all. You can see some information here, IP version 4. This is true because this is 15.0, but default gateway is not true because default gateway should be also 51. And also you can go to PC3 here, and under desktop and IP configuration, you can also see default gateway is not true here, but IP address is true and DHCP is true. And also here, DHCP is true, IP address is true because this is 30, 10, and default gateway is true. But we should go to R3 here and show run, or maybe right here, show run pipe, begin DHCP. It helps us to filter DHCP in running config. Yes, you can see we have 3 excluded addressing comments here for LAN 30, LAN 40, and LAN 50. It has been reserved, and DHCP cannot use them. But for LAN 30 and LAN 40 and LAN 50, you can see default router is not true. Default router is not true, but for LAN, only for LAN 30 is true. For LAN 40 and LAN 50 is not true, and we should fix it. We should go to configure terminal, and right here, we can write here which DHCP should be start with IP, DHCP, pool, and LAN 40 as name is very important. You should use the same name. The same name is here, LAN 40 and LAN 50. And yes, and say default router should be 192.168.40.1, and same process for LAN 50 and should be here. And if you go to, for example, PC40 here, and IP config slash renew, you can get new default gateway here, and also is same process you can use it for PC3 here, or also same, you can go to static and DHCP, and after that you can wait for here, and DHCP request successful and default gateway also is successful. Okay. We should go to check connectivity. Okay, also we can check connectivity between them. For example, you can go here and try to ping 192.168.15. I think it was 11. Yes. Yes, but it's also true. All of the devices here, PC2, PC3, PC4 can ping each other, also can ping PC1 and TFTP server. Okay, were you able to ping all IP version 4 addresses? Yes, they can ping each other. Verify that the following requirements have been met. If not, complete the configuration. Okay. Now we should verify and investigate routing protocol between three routers here. We should use OSPF, and the number of OSPF in OSPF ID is 1. And it's very important, no routing updates should be sent across interface that do not have routers connected. First, we should check OSPF. After that, we should check network, all of the network, for example, router 1, router 2, and router 3. And also, we should check passive interface. It means in this, for example, link that connected to end devices like computers, printers, and server, uh, we should activate passive interface. It means we don't have sent any advertisement and any update to PC1 because PC1 doesn't work in layer 3 and doesn't need to have any update information, cannot analyze them. In this situation, you should go to CLI here and enable and show OSPF, show IP OSPF neighbors. It's okay, but it's better. You can write here show running config. In show running config, you can see router OSPF is 1. It means ID is 1, and this is router ID. And passive interface, this is G001. G001 is passive interface. Yes, it's true because it's connected directly to PC1. And this is network address that connected directly to R1. Other network connected, and also other network connect here, and also this is white mask, and all of them is area 0. And it's same also for example, here enable show run. You can see here router OSPF. This is also for version 6. This is router OSPF 1, router ID, and also autocast and autocast reference and network. This is 10.2.2.0, 10 to 10.1.1.0, 192, 168, 20 also, and is connected to internet and ISP. And we should use net here. Okay, you should remember and this one. And also we can here also use G01 and activate passive interface G01 for TFTP server. Well, because TFTP server, like a PC, like other devices, is like an end user and doesn't need to have any information here. We can also um, use it here, and under interface G01, IP router OSPF1. Oh, excuse me, it's my bad. Router OSPF1 and passive interface G01. And same process for R3 here. So run and check also router OSPF1 and router ID and autocast and network, because they have 5 network connected here, and you can see all of the networks here, but it lacks of passive interface also. Configure terminal, because it's connected to PC2, PC3, PC4, and it doesn't need to send any update to PC3, 2, and 4. And in this situation, you can write here router OSPF1 and passive interface G01.10, excuse me, point 30, point 40, and point 50. You can also find them from here. Can you see this one and this one and this one? Yes. Other information. R2 is configured with IP version for default route pointing to the ISP and distribute the default route in the OSPF version domain. As you know, it's very important. The router that connected to internet is better. We also redistribute default route here. And if you write any redistribution, uh, default redistribution here, you can set to other routers here, I am domain, and you can send default route to me, and it's like a domain. And we should also use here. And also R2 is configured with IP version 4 default, and also it's same process for IP version 6 also, and NAT is configured on router 2, and no untrusted address are permitted to cross the internet. As we have discussed about that, you should also activate NAT uh, on G00 router 2 that connected to router 2. And also you can go here and check, and this is also can your assignment IP show IP route OSPF. You can see, for example, router 3 has learned 10110 from G020 from here, has learned it, and also 192.168.10 from also G01 from here has learned, and also 20, what is this is 20 has also learned from G02, and it's because it has because it has discussed as a two value number, As you can know, also 110, this is administrative number and value, and 2 is cost, and 649 is cost, and cost help us to find the best way and the best path, for example, to this network. And also a lot of things we can discuss about that. And in router 1, show IP OSPF, show IP route OSPF, and also you can see some information here how can learn this network and this network and this network via this, for example, uh, interface, and also serial 001 help us to get access to 192.168.20.0 for router 1. And also here show IP roles OSPF here, but we have any condition here. As you can see, router 2 is configured with IP version 4 default route pointing to the ISP. There is no default route here. And in this situation, you can go to router, configure terminal, router OSPF1, and say default information originates. It means I am router 2, say I am domain, and R3 and R1 send default route to me, and also R1 and R3 get this information from router 2. Default information originate, and it means default route should be sent to router 2. And if you go here and write again, show router IP OSPF, you can see OE2 and default route has been added to router 3. I didn't write anything in router 3, only I have written something in router 2, and router 3 also has learned from router 2 and send default route to router 2, and should send via G020, and this also IP address and this link, and this is also cost is 1 and 110. This is administrative value and ID. Yes, and same process also for PC1 also, router 1 also has learned E2. E2, it means default row that has learned from default originate. Okay? Yes, and this is the miracle of originate here. Yes, PC2 can ping outside. Yes, yes, he can. Yes, it can also. We have also corrected here, fixed here, and also check routing table on R1, R2 to make certain the default role is present. Now we have also seen it. And test also IP version 6 connectivity from router 2 to outside host and TFTP server. The ping should be successful. Troubleshoot if not yet. Okay, also you can go here and ping IP version 6, and what is the IP address here? And also this is true, and also for TFTP server under desktop, you can copy here and you can write here ping IP version 6, and after that here, and also it's true. And test IP version 6 connectivity from router 2 to PC4. This is PC4 here. Ping IP version 6 is also is true. Test IP version 6 connectivity from router 3 to outside. This is router 3 to outside. This is outside IP version 6 IP address. We can come back to router 3 and right here IP version 6, and after that it cannot ping it. If the ping fails, check the IP version 6 routes on router 3. Be sure to validate the default route originates from router 2. If the router does not appear, modify the IP version 6 OSPF configuration on router 2. Also, it's very important. We should also say in router 1 or on router 2 for IP version 6 also I am domain, and you should write here router OSPF1, and as you can see, excuse me, IP version 6 router OSPF1, and say default information originates, and it means send also to me. And now it can ping. It can ping outside. R3 can ping outside because R2 is admin, is domain, and can help R3 and R1 to get outside via this IP address. And this is default route. This is the miracle of default route. And check connectivity from R2 to the outside. Connectivity. Verify WAN technologies also. The serial link between R1 and R2 is used the backup link in case of failure and should only carry traffic if the fiber link is unavailable. The Ethernet link between R2 and 3 is fiber. Between R1 and R3 also is fiber. And take a close look at the routing table on R1. Are there any routes using the serial link? You can go here and right here show IP route, and you can see, for example, default route can get access via this serial 010, and also other thing here, for example, this one also, and this one also use also serial 010. Yes. Use the traceroute command to verify any suspicious passes. We can get from R1 get access to TFTP server here, and we want to follow which pass should be selected. It's used from R1. It's used 10.1.1.2, this 10.1.1.0 network, and also after that can get to TFTP server. But as admin, I want to change and manipulate this path, and I want to change path to TFTP server from 10.3.3.0. And what should we do? you should manipulate this metric and this cost here, and you should decrease cost here. And it means you can get access to other devices from other passes. For example, here you can see the original configuration that came from the previous serial WAN connections were transferred to the new devices. Compare the G00 interface and serial 010 interface setting. And notice they both have an OSPF cost value set. Remove the OSPF cost setting from G000 interface. It will also be necessary to remove the setting on the link R3 that connected to R1. We should go to G01 here and right here configure terminal, and on the configure terminal mode you can write here interface G001 and no IP OSPF cost. Yes. And right here do show IP routes. And something has been changed here. And also about router 3, same process. Configure terminal and interface G010 based on instruction here, and write no IP OSPF here, and you can see after that what will be happen. Reissued trace command from R1 to verify that the path has changed. Go here. Before that, have used 10.1.1.2 to access to this TFTP server, but now use 10.3.3.2 to access to TFTP server. This way and this path has been selected. And in this situation, we have modified metric and cost, and we have also changed path to access to TFTP server. And the change has been made to direct traffic over the faster link. However, the backup route needs to be tested. Shut down the G20. We want to also check backup route because also we have backup route here. And we should go here and interface G02 interface G020 and shut down, and you can see it will be red after that. And test connectivity to the TFTP server and outside host. Test again. Yes, and it's backup because R1 send packet to R3 and R3 say this is blocked and I cannot send anything to TFTP server, and R1 send this packet to TFTP server via this path, and this is backup because G020 has been blocked. Okay, and ping is successful, but other path. R2 is required to perform NAT for all networks, all internal networks. Okay. We should also activate R2 configuration for all internal network. Check NAT translation on R2. You can go here and show net translation, show IP net translation, and you can see this is blank. This is not anything here, and it means net. It doesn't work here. And also you can write here show IP net static. Yes, and it means it's not true. Okay, set the serial 000 interface as an inside interface to transit others. We should troubleshoot here. If you go here and write show run, for example, here, you can see we have access list here, access list standard net, and we have parameter 10.0.0.0 and 192.168.0.0. We don't have any problem about network address, but if you go, for example, to all of the interfaces here, interface G01, serial 000, and G010 should be inside and G00 should be outside. This is G00. This is outside. IPNet outside. This is true. What about G01? G01 IPNet is outside. Inside is also true. What about here? We have also G02. We have also 00. We don't have anything here. We don't have anything under serial 00 here. You can see there is no IPNet inside, and this is problem here. And also under G010 also IPNet inside is okay. Only we have lack of interface serial 0, 0. Oh, interface serial 0. IPNet inside because it's in the internal side. You can see only G00 is connected to outside and should be IPNet outside. Okay, and okay, we have done it also. Test connectivity to outside hosts from R1. This is R1, and now we want to connectivity to outside and ping, and can ping also outside host here. The ping should now be successful. Re-enable the G20 interface on R3. Go here and no shot and click on fast forward and also re-enable it. Okay. Devices should be configured according to the addressing table. Yes, all of them should have been configured, and every device should be able to ping every other device internally. The internal PCs should be able to ping the outside. So, for example, PC4, we can check PC4 can ping outside. Yes. For example, PC4 can ping TFTP server. This address I mean. And also ping other device also. All of them can ping each other, and also PC3 can ping, for example, outside devices here. We can check it. Yes, they can ping each other, all of them, outside, inside. PC4 should be able to ping TFTP server and outside host using also IP version 6 and version 4. So we have been pinged and we have been ping. We have pinged an IP version 6. Yes, also it can ping this IP address, IP version 6 from PC4 ping outside host IP version 6. Thank you for watching, and please subscribe me and support me and leave me any comment or question. Have a nice day.